Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is new operation. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of n integers. You can perform the following operation on it n minus 1 times. We choose an index I and we let x be equal to ai plus 2 times ai plus 1. Then we delete the current ai and ai plus 1 from the array A and then insert x back to our array. So if we have something like this, our array has a1, a2, a3 till let's say an, and we choose our I to be equal to 2, then our x will become a2 plus 2 times a3. We will delete both a2 and a3 and replace it with x. So in a way, when we are replacing a2, we are simply replacing it with a2 plus 2 into a3. Now, at the end of the n minus 1 operation, we will be left with only one element. We need to find out what is its minimum and maximum value possible. For the input format, we have t test cases, and for each test case, we'll have two lines. The first line will contain the integer n, that is length of our array A, and the second line will have n spaced integers a1, a2, a3 till an. As for the output, on a single line, we have to output two numbers, the minimum and maximum possible value of the last remaining element. As for the constraints, number of test cases will go from 1 to 100, length of our array will go from 2 to 20, and value of elements itself will go from 1 to 100. Let's see some sample inputs. So for the first sample input, our array has two elements, 5 and 10. Let's perform the operation. Let's choose I as 1. So if we choose the first element, our x will become 5 plus 2 times 10. That gives us 25. Now, even if we were to choose the second element, there is nothing else after 2. There is no third element. So this will remain the same. So to make sure that we only have one element, this is the only operation that we can perform. Therefore, both the minimum and maximum are 25. Let's see the second sample input. We have three elements that are 1, 1 and 1. Let's perform the operation on first element. Perform the first operation here. This becomes 1 plus 2 times 1. That becomes 3. So now we have 3. We delete this one and we have one more one remaining. If we again perform the operation, this will be added twice here. That will give us 5. That becomes our minimum. Let's see how we can get our maximum. To get our maximum, let's perform the operation on the second element. Now if we do that, this will be replaced by this plus this as twice. So now this becomes 1 plus 2. So this becomes 1 comma 3. Now we perform the operation on the first element. Again, we add the 3 twice here. So we get 7. Let's see how we can approach the solution. So as we have seen above, whenever we are replacing an element at I, what we are simply doing is we are simply removing the element next to it and adding its twice value to our current index. Now our goal is to have a single element remaining. So even if we want to remove all the remaining elements, we have to perform the operation at least once on them. And if we want to perform it at least once, so if we take the first element, our a1, we can keep it here if we are performing all the operation on rest of the elements, and others will have to add them at least twice. So our minimum can simply be a1 plus all the rest of the elements into twice. This will give us the minimum. We can notice here in our examples also. So in this example of 3 times 1, if we see this one was added only once, but others were added twice. Therefore, we get 1 plus 2 plus 2, giving us 5. Now how we can get the maximum? If we want to get a maximum, it is good for us if we keep on adding the elements as many times as we can. So for example, again taking the same example, when we added this one here To add this, we multiplied it by 2 and it got added here. Now, if we add it again here, the same one that was added here twice will get added here 4 times. So for example, let's take the example of A, B and C. If I'm performing the operation on B, I will replace it with B plus 2 times C, right? This is my first element, this is my second element. If I again perform the operation on 1, now it will be A plus 2 times B plus 2 into C. Now if it is performed again, we see that we are having powers of 2 here. So if I have an element something like this A, B, C, D, and we keep on performing the operation from right to left, then this element will be multiplied only once, this will be multiplied twice, this will be 4 times, and this will be 8 times. When this is multiplied to C, we'll add it twice. When you multiply it to B, it will be added 4 times. And finally, when it is added to A, it will be added 8 times. So this is power of 2's. So to find the minimum, our answer is very easy. We take the first element and then rest of the element we take twice. This gives us minimum. To get maximum, we take each element and depending on its position, we multiply the power of 2 and this will give us the maximum. At the end, we print both of them and we get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. We take the input of n. We initialize our minimum and maximum as 0 and the initial power as 1. Then we take the input of our array. While we are doing so, we construct our minimum and maximum. So for minimum, as we saw in the approach, we add the first element as it is, and for rest of the element, we add it twice. For maximum, the first element is added as it is, and for rest of the elements, we take the power of 2 as per the position and multiply it with the element. Once we are done with all the elements, we get our minimum and maximum. We print them, and as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and our array, initialize minimum and maximum as the first elements here, and the power as 2. Then for minimum, we add the element twice, and for maximum, we add the element as power that we keep on increasing by 2 each going index. At the end, we print this minimum and maximum, and as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.